Distant galaxies are neither small nor infant. Time Matters book, available in PDF, on Amazon and Google, starts with the explanation on why distant stars and galaxies look red-shifted, and it is not because our universe expands, but because time in the past was slower than it is now. 14 billion years ago time ran twice slower than it runs today, and that time difference was misinterpreted as the time of the Big Bang. 32 billion years ago time ran 12 times slower than it runs today. JWST, James Webb Space Telescope, can look back even farther, into the time when it ran 16 to 20 times slower than today. Astronomers measure redshift as number z, but for us, it is easier to track, 1 plus z, number that measures time dilation, time-speed difference. For example, twice slower time with 1 plus z equals 2 or z equals 1 was 14 billion years ago. 12 times slower time with 1 plus z equals 12 or z equals 11 was 32 billion years ago. The reason for time speeding up in the universe is explained in Chapter 11 of Time Matters book. Time dilation in the past causes another effect on observation besides redshift, refraction by Snell's law. How such refraction impacts our observation of distant stars. Time dilation in the past causes another effect on observation besides redshift, refraction by Snell's law. How such refraction impacts our observation of distant stars and galaxies, when we look from our faster time into the past when time was slower. Because line of sight is perpendicular to the time zones, both angles R and B used in Snell's law are 0, and so is sine 0 equals 0, and there is no refraction when observing a dot object like a distant star. Light crossing time zones perpendicularly does not change its direction. But distant galaxies are wider than dots, and angle of observation varies from 0 to tiny numbers. Thus, Snell's law starts playing by factoring a non-zero values by 1 plus z, which varies from 1 to 12, or even to 20, on the path from the remote galaxies. Such refraction is known as concave lensing. Lensing. Image for an observer looks smaller through concave lensing than the object itself. The farther galaxies, the smaller they appear to us, much smaller than they would look like without such lensing caused by time speeding up on the way to us. This effect on distant observations was never accounted for, even for current JWST observations, so smallness and infantility, with alleged age in 100 to 300 million year range, of distant galaxies are hugely overrated. Many of them are as mature as our Milky Way. Free Time Matters ebook in PDF, at Amazon and Google.